Assalamu alaikum dear students, welcome to physics class. I am your teacher Amir Sohail. Today we will discuss discharging a capacitor. When we need to discharge a capacitor, we connect it with a resistor like this. What is this resistor? This resistor is voltage drainage device. It eats the voltage, it eats the electrical energy. You can suppose it like an electric bulb or an electric fan, etc. Okay, so when we connect this light to this capacitor, the charge here we are having negative charge like this. This charge goes to the resistor and works on this resistor. Here if we suppose it as a light, the light converts this energy to light energy. This is electrical energy and it is converted to heat and light energy. So the energy that is possessed by these charges is dissipated over here in this light or in this resistor, and the charges after losing the energy go to the positive terminal where they balance the positive charges, and here we get the neutral charge on this plate as well as on this plate, and the capacitor in this way is discharged. Okay, when we connect a capacitor to a resistor, the discharge process is initiated immediately, and discharging starts and follows exponential curve. It follows exponential curve. Okay, what is meant by this? That this discharging happens very rapidly. It is a very rapid process, and discharging happens very quickly. It follows this equation: Q equals to Q naught e power minus T divided by RC. So T is the time at which we are going to observe the charge on this capacitor at any time. Okay, so if T is equal to 0, then we put it here and we get Q equals to Q naught. Now at this time this capacitor is having maximum charge. When we were at the position that we had not connected this capacitor to a resistor, it was completely charged and the charge present on this capacitor was maximum. So that's why at T equal to 0 the charge present on capacitor is maximum, Q naught. And when one time constant is passed at T equals to RC, Q equals to Q naught e power minus RC divided by RC e power minus 1. We get, after solving this e power minus 1, we get 0.367. Directly go to calculator and put e power minus 1. You will get 0.367 as answer, and multiplying this by 100 and dividing it by 100, we get 36.7%. So Q equals to Q naught into 36.7%. At this time, when one time constant is passed, when one RC is passed, the charge present on capacitor is 36.7% of maximum charge. And we can also get a question on it, that the ratio of charge present on capacitor after one time constant to the maximum charge is equal to 36.7%. After T equals to 2 RC, when two time constants are passed, we put 2 RC in place of time over here. Q equals to Q naught e power minus 2 RC divided by RC. Q equals to Q naught e power minus 2. Solve this, you will get like this, 2.718. This is the value of E, Euler constant, minus 2. From calculator you will get Q naught into 0.135. Multiply and divide by 100, you will get 13.5% of Q naught. When two time constants are passed, after that the capacitor is having 13.5% of maximum charge. After two time constants are passed, the capacitor is having 13.5% of maximum charge. What will happen after three time constants? We will get 5% of the maximum charge. After four time constants, solve it and you will get 99% of charge is lost, and after five time constants you can see that 99.3% of the charge is lost. Now it's a very important point that we discussed in an earlier video, that after five time constants the capacitor is completely discharged. The capacitor is completely discharged if you are going to charge it, it is completely charged. So it needs 5 time constants to charge a capacitor completely or to discharge it completely. You need 5 time constants. Coming towards these questions, a charged capacitor is discharged for a duration of 1 time constant. Capacitor is discharged. Okay, you have left a capacitor for 1 time constant. 1 time constant is passed on it, and the capacitor is discharging. You are asked this question, that capacitor is discharged how many percents? So we have already seen it over here, that when 1 time constant is passed, the charge present on capacitor is then 36.7% of maximum charge. This is the charge present on capacitor after 1 time constant. We do not need this in the question. We need the charge lost by capacitor after 1 time constant. This is the charge present on capacitor. Note it down, that this Q, what is Q? Q is the charge present on capacitor at any time t. So at this time, when 1 time constant is passed, 36.7% charge is there on capacitor. And here we are asked that they are asking us that capacitor is discharged how many percents? So capacitor is discharged 100 minus 36.7%, which is the charge still present on capacitor. So 63.3% is the charge that is lost by capacitor. So capacitor is discharged up to 63.3%. Previously, when we were discussing the charging equation, that charging equation was giving us the charge present on capacitor at any time t. At this point, this equation also gives us the charge present on capacitor at any time t. So for the charging case, it was relevant. It was completely in synchronization with that concept, because there we were having percent of charge present, percent up to which capacitor is charged. Here we are having percent up to which capacitor is discharged. So it is negative to the equation. It is opposite to the equation. That's why we will subtract it from 100 to get the value of the percentage up to which the capacitor is discharged. It is question number 2. A charged capacitor 300 microfarad is connected to a resistor 5 ohms. The capacitor discharges 86% after how much time? Okay, you are having C equals to 300 microfarad and R equals to 5 ohm. Now they are asking you that tell us the capacitor is discharged 86% after how much time? So first of all, we will find the time constant for this very system, in which capacitance is 300 microfarad and resistance is 5 ohm. Let's see, after t equals to 2 RC, double of time constant, we have already studied that charge present on capacitor is 13.5% of Q naught. And if we want to find out the charge lost by capacitor, we will again subtract it from 100. We will get 86.5%, which is approximately equal to 86%. After 2 RC, 86% discharging has occurred. And now we are going to find 2 RC, 2 R. R is 5 ohms, that is given, and C is 300 microfarad, that is also given. So we put the values 2 multiplied by 5 multiplied by 300 micros, 2 multiplied by 1500 micros, and 3000 micros, 3 multiplied 10 power 3. We can write it like this, and micro is 10 power minus 6. It comes out to be 3 multiplied 10 power minus 3 milliseconds. Okay, so capacitor is discharged 86% after 3 milliseconds. Remember this thing, capacitor is discharged 63.3% after 1 time constant. Capacitor is discharged 86% or 86.5% after 2 time constants. And also we have studied it, or you can find it out from the previous study, that capacitor discharges up to 95%, up to 90% let's see it here. After 3 time constants, we are having 5% charge. So 95%. Capacitor discharges 95% after 3 time constants. Capacitor discharges 99%. 99%. There is a bit of mistake over here. Let me change it. It is 1% and it is 0.7%. Now we are having after 4 time constant 1% charge on capacitor. We are having 0.7% of maximum charge on capacitor after 5 time constants. Okay, so after 4 time constant 99% charge is lost by capacitor. After 5 time constants 99.3% charge is lost by capacitor during discharging. A fully charged capacitor, once again the same question, but a bit of change. The charge present on capacitor after 3 millisecond is dash. We have already found it that the charge present after 3 milliseconds, we are having the same values of R and C. So after 3 milliseconds, we are having how much charge? 13.5% charge, 13.5% of maximum charge. So this is the right answer. The charge present on capacitor after 3 milliseconds. The charge present on capacitor after 2 time constants. In this case, 2 time constants. 2 RC is 3 milliseconds for this system. Okay, and after 2 RC, we already know that the charge present on capacitor is 13.5% of maximum charge. Okay, these are some points you must have in your mind. Capacitor discharges completely after 5 time constants. We have discussed it. Charging and discharging speed is related to RC value, time constant value. Large RC means slow charging. Small RC slow discharging. Small RC means fast discharging. We have discussed it in charging that when the value of R or C or both is high, then charging and discharging process will be slow. And we are having the value of R and C or both is small, so then the charging and discharging process will be fast. Let's have a recap of the topic. Remember these points. At T equals to RC, we are having 36.7% of charge left on capacitor. At T equals to 2 RC, 13.5% of maximum charge is left on capacitor. At T equals to 3 RC, 5%. At T equals to 4 RC, 1% of maximum charge. At T equals to 5 RC, 0.7% of maximum charge is there on capacitor. These values are supposed to be remembered as well. Okay, thanks a lot. Have a good time.